Here we have a series and parallel circuit. It's series and parallel because we have the 4, and the 6 ohm resistors that share the same voltage. They're in parallel with each other. Now we're tempted to find the current through the 6 ohm resistor by using Ohm's law, which is just voltage over resistance. And we know the resistance is 6 ohms. What we don't know, though, is the voltage. We know the circuit gets 60 volts, but some of that is lost to the 2 ohm resistor and some is lost to the 2.5 ohm resistor. So what we're going to do is we're going to try to replace the 3 in parallel with what's called an equivalent resistance. Okay, that's the equivalent resistance of the 4 and the 6 ohm resistors. The easiest way to do that is to use your calculator. So we would take the inverse of 4 plus the inverse of 4 plus the inverse of 6, but we need then to take the inverse of that to come up with an equivalent resistance of the parallel circuit of 1.5 ohms. At that point, we can find the overall resistance in the system because we just have, at that point, 3 resistors in series, the 2 ohm, the new 1.5 ohm resistor, and the 2.5 ohm resistor, or a total of 6 ohms for the system resistance. That's going to then let us calculate the current coming out of the battery, the system current, which is always the largest current in the system, which would just be the 60 volts of the system over the 6 ohms total resistance, or 10 amps. That's 10 amps coming out of the battery, but because there's no node between the battery and the 2 ohms, then the 2 ohms also gets 10 amps, or a voltage of 10 amps times 2 ohms, which would be 20 volts. In a similar fashion, we know that the current going into the battery must also be 10 amps. So the 2.5 ohm resistor also gets 10 amps, or a voltage of 2.5 times 10, or 25 volts. Those are both voltage drops, which means if we started with 60 volts provided by the battery, and we lose 25 volts at one resistance and 20 volts at the other 2 ohm resistor, then the total voltage remaining for the parallel part of the circuit would be the 60 volts minus the 20 minus the 25, or a voltage for the parallel group of 15 volts. That finally lets us calculate the current we want, which is the current through the 6 ohm resistor, because now we can just say it's 15 volts divided by the 6 ohms, which gives us a current of 2.5 amps. Now at this point, if we wanted to, we also could say, well, the 4 ohm resistors, they must have the same amps, and they do. They have 15 volts over 4 ohms, which would be 3.75 amps apiece. So double the 3.75 and add the 2.5 amps, and you get what you would expect, 10 amps coming back out of that node. And so we wouldn't have voltage here. We would have the current going back through the 2.5 ohm resistor of 10 amps.